Welcome everybody to Time is an Illusion. Well, time is an illusion, and when I find my technical problem solved, I hope that it will be also working. Yes, and time is an illusion, and you already said so. Lunchtime, doubly so, because well, for me it is morning, for others it is evening, and for some of you it might even be lunchtime. So. I came upon this when I, in 2018, read a tweet by Cal Evans, a friend of mine, who started every day with an encouraging message on Twitter, and he posted out a heartily "Good morning." And I looked at the time, and it was like 2 o'clock in the afternoon for me, and I was like, "What the hell is going on here?" That was the point where I realized, yeah, time is hard, or time zones are hard. So who am I? Sammy already introduced me. I'm a software development company called bitExpert. I'm co-organizing a PHP user group, head behind PHP UJ, callingallpapers.com, and I'm contributing to Joined In. You can find me on the internet. If you have any questions, feel free to ping me. But due to the stuff I'm doing for PHP UG and especially Calling All Papers and Joined In, I had a lot of knowledge about time zones, or I had to dabble with them. And I want to share a bit of that with you. But first and for all, I would really be happy about some feedback for that talk. So if you think that there is something that I could improve on, please feel free to leave me feedback on Joined In. And now let's dive into the whole thing. This is something that Sammy perhaps might have seen already in Natural. This is the first coffin to the first nail to the coffin of time zones. This is a golden nail that was put into that marked the merging of the railway between the West Coast and the East Coast in the United States. There was a huge party when those two railroads met, and this was celebrated with inserting a golden nail into the railroad as the final point where people now could travel from the east to the west by train, or from the west to the east. And that was great, but people very fastly realized that it was perhaps a bit interesting in getting the right time for when the train actually arrived at a station in between. Because, well, the United States are pretty large, well, not as large as Russia, but they were the first that had the problem that when a train started out in San Francisco on its way to New York, it traveled more or less 4 or 5 time zones. And so the times for the trains on the stations in between had to be calculated in a kind of interesting way, so that people actually knew when to catch the train and weren't late or too early. So in 1800 and whatnot, 1883, the bosses of the different railroads that were part of that network met and decided on a way to make calculations of time zone or of timetables for trains easier. So they met and they decided, okay, let's divide the whole country into 4 different zones. And each of these different zones should have an hour offset to another, or to the next one. So that would make calculation of timetables much easier, because now suddenly people could know, oh, okay, I'm in this time zone, so the train stops at this specific time, 12 o'clock specific, on this at this station. And how did they transport that information when to actually switch the time from local time to that specific time? Well, they used Morse code. They used the telegraph that was invented, so they could actually rather reliably send a message or a signal from East Coast to West Coast in almost no time, and everyone on the line could then set their clocks to the appropriate time. Why is that necessary? Because the Earth is not flat, as some people might believe. The Earth is round. And as we see in this great image from, I think, one of the Apollo missions, there is a part that is always covered by darkness, and there is a part always light. And we as humans are used to calling the light part the day and the dark part the night. And it is much easier to work during the day part. So we decided at one point in time, okay, when the sun is at its highest point, this is called noon. And from that on, we calculate our times. But as the Earth revolves and the light and the dark side moves, well, so do these times move. And the noon moves kind of around the globe. So when it is noon here in my area, it is already 1 o'clock in Moscow time. Or actually, from the sun point of view, it might even be 1:30. So because this is what it more or less at this point in time looks like. We have the sun at around the area of Africa, and the moon is at this point in time over South America. And the South America and the United States are more or less covered in darkness. So it's rather late for them. So I assume Sammy has about 10 o'clock in the evening at his area. So how do we cover that, or how can we cover that or how can we handle that in times? Well, people then decided, okay, we have 24 hours, so just let's divide the whole world into 24 zones that have 1 hour offset, as they did in the United States. And over the sea, that is pretty easy because that's just a straight line. But on land, that becomes rather cluttered. Because sadly, it's not that easy as drawing a straight line over a country, because, well, governments. So the different countries decided on different rules, and perhaps a country also had to decide on different rules within the country because of its sheer size, like Russia or like the United States. And so one of the main things is that we have to remember if we're talking about time zones is that a time zone is a part of the Earth's surface that by governmental definition has the same date and time. And this is the thing that usually bites us as developers, this governmental definition. Because from a sensible point of view, everything is pretty clear. There are 24 different zones, so that's easy. But governmental definition means suddenly people are in charge and people can have weird definitions or weird ideas. I said that usually the offset is 1 hour, but that is just, as I said, usual. Nepal, for example, has an offset of 4 hours and 25 minutes, 4 hours and 15 minutes. Or Venezuela, for example, has an offset of 4 hours and a half. So there are political decisions that make life much harder. So an offset. What is an offset? An offset needs some specifics in time, because usually we're saying, yes, this is an offset from Greenwich Mean Time. So let's have a look at what is this time coordinate, this offset that this time that we are calculating the offset from. In the beginning, there was the Greenwich Mean Time. Greenwich Mean Time is based on the fact that noon depends on the sun. So when the sun is at its highest point, this is called noon. That can be calculated or observed. The problem is that throughout the year, this can lead to differences of up to 6 due to the differences in the Earth rotation. This equalizes out over the year, but well, that can make calculations pretty difficult. And so at one point in time, when physics demanded more precise times, there was the invention of the universal time, or in French, pardon my French, Temps atomique international, so the international atomic time, which depends on an atomic clock. And that was started in about 1955. And this is completely independent from a solar orbit. It's just counting the seconds based on the wavelength of an atom. The problem is that by 2015, there was already an offset of 36 seconds against, well, Greenwich Mean Time. That's not that much, but it means, yes, there is an offset. So it doesn't 100% work out. And that was the point in time, or when people realized that was the point in time where they said, okay, we need a universal time, but coordinated with the solar noon, which was the birth of UTC, which is the universal time, but in a coordinated fashion. And this is based on the Temps atomique international, so on an atomic clock, which was started in 1961. And the main thing is this adds leap seconds every now and then. And this every now and then means exactly that. It's not calculated. It has to be observed, because the idea is to have the offset between UTC and Greenwich Mean Time at 0.9 seconds max, so that we don't have more than 1 second or a second or more offset between UTC and Greenwich Mean Time. So, having said this, we need to make some definitions, caveats. What are those? So we are talking about time zones. A time zone is a geographical region that by governmental definition shares the same coordinated time with an offset from UTC, or sometimes from Greenwich Mean Time. There is also time ID, which is the identifier for the geographical region. We come to that in a second. And then there is also the time zone abbreviation, which is a sum of geographical regions that share the same coordinated time. And then there is the zone time, which is the time offset against UTC or Greenwich Mean Time of a geographical region. This sounds pretty complicated, I imagine, but that's actually the easy part. Because to make it complex, I said it, time zones are by governmental decisions. So governments decide sometimes weird things, and they can decide one thing and 2 months later the other thing. So time zones actually change. And this is something that happens quite frequently in Russia, actually. I think there is almost no change in the time zone database, to which we come later, where there is no change in Russia. And that is not only because some political areas are shifting from one time zone to another. That is also due to some smaller things, like let's have a look if you can see this one, this part here, down here. This little bubble, which is missing on the lower, image, but is missing on the upper image, which is the Krim area. So time zones can also change because of political decisions, because of war, because of whatever the reason might be. Just to make that clear, just because some time zone changes within the time zone database for a certain region, that does not mean that that is a political right decision. That's just to help people in that area to make the right changes, or to get the right information. This is usually a very heated debate on the time zone mailing list. So time zones change frequently. The question is not, will the time zone change? The question is always, when will the time zone change? Okay, so that's quite complex. But to make it even more complex, yes, my country invented something, or actually, well, at least started something 104 years ago, which was summertime. In 1916, that was during the First World War. People realized, oh, we need more fuel for our tanks, so we have to save on fuel, so we can't have that much fuel spent on lighting, so we need to extend the daylight, and so we need to do something about that. And so they invented summertime, or what it is usually called daylight saving time. Daylight saving time starts at different times in the throughout the globe. So we come to that in a second. And usually the offset is 1 hour, but that doesn't necessarily mean it has to be 1 hour. It can also be just 30 minutes or whatever government thinks makes sense. And summertime or daylight saving time does not need to be only once during the year. It can also be multiple times. For example, in Germany after the Second World War, we decided, yes, in May we are going to have summertime, daylight saving time. And then in June or July, I think, government decided, oh, you know what, let's have another round of daylight saving time and add another hour offset to the whole thing. So now we had, instead of 2 hours offset, we had 3 hours offset. And then in August, we went back 1 hour, and in October, I think, back another hour. Or what happens frequently in African countries, for example, is that they have summertime or daylight saving time, and then suddenly say, okay, now we are switching back to standard time, and a month later we are switching back to daylight saving time, and 3 months later back to summertime, to standard time. Why do they do that? Because usually during that month where they use the standard time, they have Ramadan, and as Muslim country, people are allowed to eat as soon as the sun goes down, and that happens earlier during the default time. So yes, summertime can be very intimidating. How do you know when those transitions are? Well, in PHP we can get actually the different transitions for the different areas. And in this case, for example, these are the transitions for this year for my area. So on the 29th of March, we went to 7,200 seconds offset from UTC. And on the 25th of 10, we are going back to 3,600 seconds offset from UTC. So back to 1 hour offset. Yeah, daylight saving time is not simply 1 hour offset. It can be 2, it can be in half an hour, whatever you think. Daylight saving time starts at different times throughout the world. So daylight saving time in Europe, for example, starts at a point or a different time than, for example, on the North American continent. And it is at different seasons throughout the hemispheres, because what we in the northern hemisphere call summer is winter in the southern hemisphere. So in the southern hemisphere, usually they have daylight saving time throughout our winter. And also you have to be prepared for days with 23 or 25 hours or even more or less. Depends on what happens. You can also be prepared for days with, actually 0 hours, because at one point in time, a small island in the Pacific area actually switched from 1 day to 2 days in advance. And they skipped a whole day because they moved from, what was that? I think minus 13 offset to they switched from plus 13 to minus 12 or something like that, because they decided we're not doing that much business with Australia. We're doing much more business with America, so we want to be more near to them. Yes. And daylight saving time can occur more than once a year. So then, the summary is, time zones are political definitions. Time zones do change. And time zone abbreviations cover a stripe from North Pole to South Pole. So the time zone abbreviation might be something like Central European time, which covers a whole stripe from north to south, or at least a part of it. The zone time, on the other hand, is defined by the offset from UTC. And most important things is the daylight savings time may add or remove time from or to the zone time, not from the time zone. So when we have daylight saving time, the time zone does not change. The time zone will still be Europe Berlin or Europe Moscow, but the offset of within that time will change, and so the zone time will change. So that's it about for the basics. I hope I didn't confuse you too much, but now I think we're going, now that we have set the basics, we're going to understand a bit more of what is happening within PHP. In PHP, there is the DateTimeZone class, which is the main thing when we are handling time zones. So we can instantiate a time zone object with, for example, like this. We create a new DateTimeZone object with an offset of 3 hours, which is fine. We get a time zone object with a time zone type of 1, and that has a time zone, well, as time zone, we have plus 3 hours. Perfect. We can also use plus 3 hours and 15 minutes or whatever you want. We can also initialize the whole thing with a new DateTimeZone MSK, which is the time zone abbreviation. And that gives us a time zone of type 2 with the time zone MSK. And then we can also say, yes, we create a new time zone Europe-Moscow, which gives us a time zone type 3, and the time zone is now Europe-Moscow. That's fine. But why are there these 3 different things? What happens internally? Well, let's have a look at the Europe-Moscow time zone if we call getLocation. This returns us an array with a country code of RU, like Russia, and with a latitude and a longitude, and with a comment which is Moscow area plus 0. If you wonder, those geographical coordinates are just outside the Kremlin between the History Museum and the Museum of the Patriotic War of 1812. I have no idea why it's exactly those coordinates. If someone can find that out, that would be really awesome. Okay, so what happens if we call this getLocation on one of the other 2 ways of instantiating a DateTimeZone object? Well, if we create a new DateTimeZone object MSK and call getLocation, we get exactly nothing. Because MSK covers much more than just one time zone. It covers, I think it was 13 or 16. We'll see that in a later example. So we don't know what geographic location might that be. Worst case would be, yeah, it's somewhere on the equator. So it doesn't help us in that part. And the same happens if we initiate a DateTimeZone object just with an offset. We just don't know where that might be. So we have lost information here if we use DateTime just with an offset or with the time zone abbreviation. So as I said, time zone informations change. So one of the first things I usually do when I work with something PHP related, I'm doing the PHP -e and grep for Olsen, because the time zone database is called the Olsen database also. And at this point in time, you should see this output. The current time zone database is 2021. Though if you're using the latest PHP 7.4.5, I think, that was built or released just before the last time zone database release. So this still 2019.3, I think. So if you want to stay on top and if you want to stay current, which you should, there is a pickle package, TimeZone-DB, which just replaces the time zone information if you cannot update your PHP version, because with every new PHP version, you will always get the latest, well, at the point of release, the latest time zone information. And of course, at iana.org/timezones, you can always download the latest raw data and do whatever you want with it. So how do we handle date times in PHP, or how we should handle date times in PHP? One of the main things is please do not rely on server time, because who knows whether the server is actually set to UTC or whatever. You should always use datetime with time zone information for user-related dates, or use the datetime with UTC as a time zone for server-related days. What is this information, or this difference between user-related dates and server-related dates? Well, for example, logging information, stuff where you are creating a timestamp or need the time of something that is happening right now, you usually know how to convert that to UTC. So you can use UTC as the time zone, and well, as you know, it's UTC. You don't need to store the actual time zone. As soon as you have date information that might be a bit in the future or a bit back, it might happen that between now and the actual date time that something happens, this time zone information might change, and that change might affect you. So in this case, you should store the time zone, the date time, with the time zone information of the location that you're referring to. And one of the big things, please always use DateTimeImmutable, which, as Derek mentioned one time, is what datetime should have been in the first place. So how do we handle date times? Well, okay, first thing I said, we create a date time zone object, Europe, Moscow, and then we create a datetime immutable 2025-13, 10:30, which is about now. And we add the time zone to the datetime immutable object. And then when we do an echo date format C, we get the current information. Perfect. And to know what time it is, for example, in the Phoenix area in America, we can just say, okay, set time zone, new date time zone, America Phoenix, and do an echo date format C, and we get, okay, it's 0:30 with an offset of -7. So that's pretty early in the morning, and I assume that some people are not awake yet. So Sammy, what are you doing here? But take care. You can instantiate datetime immutable, for example, just with the letter A, which gives you a perfectly valid timestamp. It gives you 2025-13, so the 13th of May. So today it gives you 10:30 with an offset of 1 hour. Perfect. You can do that also with new datetime immutable B, C, D, whatever you want. Unless you say new datetime immutable J, which suddenly will give you a warning, uncaught exception, datetime construct failed to parse string at position 0. Time zone could not be found. What the hell? Well, you can instantiate a datetime object with a time zone. And there are different time zones. We've seen that already. We had the plus, the offset version. We had the actual time zone identifier like Europe, Moscow. And we also had the time zone abbreviation. I've shown you MSK for the Moscow time, but there is also an abbreviation of A, B, C, D, E, etc., which is military time. So A, for example, is Alpha time, Z is Zulu time, which is offset of 0. And as the alphabet has 26 characters, 24 are used for the offsets. Z or Zulu is used for the 0 time zone. And so there is one character missing. And as I and J can be mistaken for one another, J doesn't exist. So we are here trying to instantiate a datetime immutable object with a not existing time zone, which just doesn't work. Just remember that if you have issues with stuff like that. So far, everything is fine. How do we store date times? Well, as I said, we need the time and we need the time zone information. It makes sense to actually store date times by using 2 fields. One for the actual date time with the local or the UTC time, and one field, one string for the associated time zone, not for the offset, please, because if you use the offset, you don't know, you're losing information. So it looks like that. For example, we do a PDO statement, we insert into event the values datetime and the time zone. And the time zone information comes from datetime get time zone get name, and the datetime comes from, well, datetime format and then the appropriate format for your database, whatever that is. We have a look at databases later on. Because if you do that, you can now do a select from event and can pass the information you get back from the datetime and from the time zone directly back into new DateTimeImmutable. So now you have a perfect DateTimeImmutable object that you can then use and do time zone calculations like whatever you want. For MySQL, you can even do time zone calculations right within the database. But for that, you actually need to prepare your MySQL database. So you have to push the zone information that is usually located in user shared zone info into the database in a certain format. So there is as soon as you have MySQL installed, you usually have this MySQL tz-info to SQL command, which takes the information from the zone info file and pushes that then, or converts that into SQL statements that you can then push to your MySQL database. If you have done that, you are now able, make sure you have the correct time zone data. Sorry, yes. So you have to redo this every time new time zone information has been released. If you do this, you can then do a bit of time zone calculation magic within MySQL. If you want to select stuff or events where event time is later than, for example, in this case, 1400, select star from table where date format, convert time zone from my local date time and the local time zone field that I have, convert that into UTC, and check where the %H value, which is the hour, is 14. And then you get the information. Or you can select where convert time zone from my datetime, my time zone to UTC is 1400. So that's pretty nifty. For those that are not using MySQL, you can use Postgres. You can use that with Postgres, of course, as well. If you're using Postgres, please, please, please do not use timestamp with time zone as your date type, because it's misleading. It's not storing a timestamp with time zone. It's storing a timestamp with an offset, and you will lose information. Why is losing information so vital in this case? Well, if you are storing, for example, this is something that happens at a certain date and time in the time zone Europe Berlin, you know, okay, there are some rules in place that distinguish between summertime or daylight saving time and standard time. If you're just saving the offset, you're saving, for example, for an event that is happening now, you're saving plus 2 hours. But you don't know anymore whether that was during daylight saving time or not. If at one point in time people or the government says, we don't want summertime, you don't know whether you have to recalculate the information or not, because you just know, yeah, that was an offset of 2 hours. So if you're using Postgres, you don't have to worry about this passing in the datetime or the time zone information, because that has already been taken care for. But you can do the same calculations as in MySQL. It's just a bit different syntax. So here we select star from table where, and now we extract the hour from the time at the time zone at the time with the zone UTC. So we are doing two calculations or two time zone calculations here. The first one just says, yes, take the time at our time zone. And the second one says convert C and then extract the hour, which is 14 or whatever. And then we can check which one is earlier or later. Okay, now we know how to handle them. Now we know how to store time zones, but we have to get the time zone in the first place. So how do you get user time zones in the first place? Well, actually, there is no reliable automated way. The only reliable way is actually to say, yeah, give me the time zone you want this event to be in, or give me the location where this event or this thing happens. Well, you might now say, yeah, well, but what about Moment.js, which has a guess my time zone thingy going on? Okay, I prepared this for you. So let's have a look. Time zone moment tz guess. That is nothing else than that's what this button does. So let's have a look what guess my time zone does. And it guesses the time zone. And okay, nope. That definitely is not the time zone I'm currently in. So this does not always work effectively. And this is Firefox. I know that in Firefox that can be an issue. It might work. On the other hand, I've seen other Firefox browsers where it works. So depending on the browser you're using, it's not reliable. So you probably should give the user an option to optimize this information. How do you get the time zones for a country? If you know the country, so you could just give the person a time zone to select for that country. Well, you can use DateTimeZone list identifiers and then per country, and the country is Russia. And here in this case, we see, yes, we have some entries for Russia, a whole lot of 25, which is quite a number. Even in Germany, we have 2 time zones. In other countries, it might be less. Well, you could always present that to the user and say, okay, select your time zone. But the much more elegant solution would be to say, okay, where do you want this event to take place? Take the latitude and the longitude and pass that to an API. There is a timezone DB API that you can pass latitude and longitude to, and that will then return you the current time zone and some additional information. You can even pass a timestamp to that. So it will give you back the time zone that location was in at this specific timestamp, which might change, as we learned earlier. So how do we get time zones for abbreviations? I earlier said that there is no reliable way of getting a time zone back if we have an abbreviation. So if we do a list abbreviations, for example, for the abbreviation MSK, it will give us 13 different time zones we are in. And the, for me, most interesting thing was, okay, we have here Europe Moscow as the first one with an offset of 10,800 seconds. And then we have Europe Simferopol with an offset of 14,400 seconds. How does that work? So even though we have the same time zone abbreviation here, we have different offsets. I'm not 100% sure whether Europe Simferopol perhaps observes daylight saving time and Europe Moscow does not observe daylight saving time. But as the DST array key is empty, I assume Simferopol also doesn't observe daylight saving time. So I have no clue what happened here. This is definitely something that I need to investigate on. But I didn't get around to doing that when I prepared for this, or when I set up these slides. So you see that you're losing information. If we know it's in MSK, we don't know, was it in Moscow, was it in Simferopol, where was it, the event? So if you're handling date times and time zones, please do not try to get a time zone from an offset or an abbreviation, because you've just seen it doesn't work. Please also don't do funny timestamp arithmetics within the database. And with timestamp arithmetics, I mean like adding 3,600 seconds or 7,200 seconds or whatever amount of seconds, because for one thing, you don't know whether there is daylight saving time. For a second thing, you don't know whether perhaps there are some leap seconds and you're getting off information, or if you have a shift of daylight saving time to standard time or the other way around. So you will definitely get wrong results at one point or another if you're doing timestamp arithmetics. Please also don't store offsets in your database because you will lose the information. And you should also perhaps not rely on datetime functions of the database because they might not exist. So doing these nice time zone arithmetics in MySQL or in Postgres are a nice thing. But if you have something that relies, or a product that can be set up by the customer, you don't know whether they're might be using MySQL and haven't set up their time zone information, or perhaps they're using SQLite and SQLite just doesn't have the datetime functions. So you need to be sure that the datetime functions of the database are existing. Otherwise, you need to take other measures to use that. And please also do not convert datetimes to UTC or to an offset, because you will lose information and you will perhaps get wrong information in the end. I'm pretty happy to discuss that later on in the chat. I've also written a blog post that I've linked to later in the slides, so feel free to ping me on that, because this is usually the thing. Yeah, we convert everything to UTC and then we will also be in trouble. Please also don't use time zone identifiers for user interaction, because those are identifiers. You are also usually not usually don't let your users interact with your identifiers for your data records, whether those are UUIDs or whatever. Those are just internal representations or internal identifiers for the time zone database that are not used or should not be used for user interaction. But what should you do on the other hand? Well, okay, let's have a look at that. Please do use UTC for logging information, because you're now at the certain point in time and you should know how to convert your local time to UTC. Apart from those few cases where the time zone database maintainers were informed about a change in daylight saving time calculations or whatever, like 3 days after the event actually happened, which happens sometimes. And then you have a problem here, but usually it is safe to use UTC for logging information. Please do store datetimes without offset as local time, and then store the time zone name with the datetime, which is the time zone identifier, like Europe, Moscow. And of course, if you know you're storing that as UTC, you can omit that time zone name because you know it's UTC. And for rendering, you should use Moment.js or something like that, so that the rendering is not done on the server but on the client, because then you can actually take into account what the user might want to see. And for displaying time zone names, please use the ICU informations, or just let the user decide on a geographic location, whether that is on a map or wherever, and then revert that into time zone information using an API or whatever other means you might find. Because in the end, datetime without time zone is a tiny bit like money without currency, and you wouldn't do that either. So that's it about. So the only thing that remains for me is, yes, remind you of feedback. That would be really amazing. And I think we might have some time for some questions. So perhaps if there are questions, we can have them now or later in the chat. Feel free to do that. Just as a short reminder, I have added some links here. I will upload the slides later on. So have a look at these links. Especially something that always comes up is like, what about time on Mars? Yes, people already thought about that. Have a look at them if you want deeper information. And so if there are some questions, I'm happy to answer them, at least a few of them now. Do we have the possibility to answer questions anyhow?
Coming in through the Zoom room. If you would like to join Andreas and others for some Q&A, if you would look, there should be a link showing up in the chat to link you to the Zoom room.
I will then,
and then you can ask some questions.
Exactly. I will then leave here and go over to the Q&A Zoom room. So here on this place, all I can do is say thank you very much for your time, and I'll now join the Zoom room, which might take some time, but I will manage to do that. So
if you join us in the Zoom room, So Andreas, if you don't mind, I do have a question for you. I'm going to actually close out Zoom for just a second because I'm getting quite an echo, and it's hard to understand what I'm actually saying here. We do have a question from Constantine, which I do not have in front of me, unfortunately, at the moment. But I will make sure that we can get Constantine's question.
Yeah, we're waiting. Yeah.
Yeah, I am online. I don't hear. Oh, okay. Hi, Andreas. I'm Konstantin. Thanks for your talk. It was really great. I have a bunch of questions. You already told us there are a bunch of caveats when working with time zones. Maybe you have some general tips that will help developers to prevent some rough mistakes. I mean that you have many edges where you can manipulate time zones. Server configuration, database configurations, database store, your server-side code, your front-end side. Maybe you have some tips where to store, where manipulate, maybe just pass raw data to the client side and just manipulate there. What are your thoughts on this?
Andreas is
All right, Constantine, I think we just lost Andreas, unfortunately. I would love to answer your question, but I'm not the expert on date time, so I wouldn't be able to answer that, unfortunately. But I think we're going to try to get Andreas back as soon as possible here. I have a list of questions for him as well, so once we get him back, we'll bombard him with questions. Where are you from?
I'm from Moscow, Kiev. UTC +3 offset.
I'm UTC -7.
Yeah, far
so
away.
Are you actually in Kiev or Moscow?
Right now I'm in Kiev, yeah.
Okay, cool. Yeah, I was in Kiev for a little while. It was it's quite a lovely place, and I love how deep the subway stations are. You get on the escalator and you just go down and you go down and you go down. You're like, when is this thing ever going to stop? And then you finally get down there and you're like, I must be like close to the center of the earth now because that took forever to get down here. Isn't it? Aren't they some of the deepest subway stations in the world there?
Really don't know. I know that in Moscow there is a few really deep stations, metro stations like Aviamotorная or some other. Don't know what about worldwide.
So have you been doing PHP programming for a long time?
Yes or no. Right now, mostly doing software architecture, not writing PHP most of the time, but love it, yeah, for a long time.
Gotcha.
That should work now. Does that work now?
Yeah, we're hearing you.
Okay, great.
Now,
bombard me with the questions.
Yeah.
The question was how to handle date times within applications. Well, the first thing is handling them within the application. There is no way around the datetime object. And adding the time zone information as detailed as possible. So if you have the actual time zone identifier, that is really, really helpful. And because if you have that, you can then do time zone arithmetics in the datetime object or DateTimeImmutable object, because you just say, okay, give me this or set the time zone to something else, and now you get the different times, the different time information for that. You can convert it via that to UTC for the current point in time. That's rather straightforward, actually. So there is no need of doing some mathematics with seconds or days or whatever I come across in Stack Overflow. It gets interesting if you want to store that in the database, because I usually would store that as local time. So the time zone information that I have, and aggregate that then back on creating the DateTimeImmutable object. So that's on the backend part. And for the front end part, I would actually just pass exactly these information, the local time and the time zone, to the front end, and then let JavaScript do the rendering. Does that somehow answer the question?
Yeah. What do you think about manipulating data on the server side? I mean, you can you already said that it's not good to use some database functions, because there are different databases, different server configurations, but where to manipulate it? Because databases already have, if for example, Postgres or Oracle, some other have really good time zone manipulating operations, functions. Why not to use them within database, near with your data, and just to send back to client already prepared information? Or is it good to manipulate them on your business logic side, just to distinguish between databases storage or not any kind of storage and your application?
So the first thing is, if you have, for example, an event like this conference, it has a start time and an end time, for example, and there is actually no need to manipulate that data, because the start date is 10 o'clock or 9:45 or whatever, Moscow time. So there is no need in manipulating that. If you want to display that for the user, or in the time zone of the user that is currently visiting the website, you can just push out that information 10 o'clock Moscow time to the front end, and the front end then decides on how to render that based on the user's information. So there is no need in actually doing any manipulation. If you have to do manipulations, you always need to take into account that the time zone information might change for future information or for future events. So calculations that you do now might not be valid in the future. That is why I would most of the time would try to avoid manipulating that information. Of course, you can use the time zone or the datetime functionality of a database. If you know my application is running on Postgres and it will always be running on Postgres, of course you can use the information there. Apart from perhaps the fact that that might be rather slow, because doing such calculations in a select means that you actually have to query each and every table row, which can get quite time consuming. So it might be more of interest to calculate back to UTC, for example, to have the information in an indexed field, but that is only an additional field, because as soon as you have a new version of the time zone database, you need to recalculate that information, because now the time zone information has changed, some information might have changed as well. So you still need the original information of the date time and of the time zone to recalculate your index column, so to say.
Yeah, great. We have also some questions from the Zoom chat. People think are not going to ask themselves, so I'll name one of them. What is how to store the historicity of the user logs if there are constant change of the data on time zones? I think Alexei mean that when you store data, there are some offsets, daylight savings, yes, and then after a few months, years, or some time ago, this can be changed in the future. So how can we analyze that in historical perspective?
The time zone database came into existence in I don't know exactly. I think it was during the 80s, perhaps 90s. So everything that happened since then is actually pretty solid. So there is no change in historical information from that time to be expected. So if you're calculating, if you have historical data from, I don't know, 2 years back or something like that, that will not change. Different story is that with time zone information from time before 1970, because at that point in time, and the further you go, the more unreliable it becomes, because at that point in time, the historic data actually changes sometimes. People dig out new information and then the historic information on the database is changed. But that should not include any logging information that we already have. So if you have logging information like that, you're fairly safe. And if you have logging information, as I said before, you can usually put that into, transfer that into UTC on the time of creation. So you have then UTC information, and that's pretty solid.
Yeah, thanks. Great. We have another questions. What are the best options to allow users to tell us as developers what are their time zone upon registration? For example, you already showed that time zone guessing is working really bad and not always can have a good answer. I know that some sites, some applications, web applications, for example, show when you first came, open the site, show a little banner with, are you in Moscow time zone? We guessed yes, no. So you can quickly change this. Maybe you can show us some other good examples of how can this be handled.
That is a good way, for example, because that in my case that would me show, yes, you're in Africa. What was that, Abu Dhabi? No, and then I would say no, that's definitely not the time zone I'm in, and I would want to change that, and then I can select what time zone I'm in. Perfect idea. The other possibility would be like for an event, for example, where does the event take place? You usually have a location for the event. So you can then use that location, convert that into latitude, longitude information, for example, with the Google Maps API or Nominatim API, and then use that lat long information to get the time zone for that using another API. That would be another way, or just present the user with a select button. What time zone do you think you're in, or do you want to be in? And then the user can decide for themselves what time zone they want their information to be displayed in. Because it also happens, perhaps not as often and not as frequently, that people are traveling and they are in a different area, and suddenly their guest time zone is like wherever they are now, but they want their time zone information to be from where they are used to be, because that's how they calculate their time information mentally.
Oh, okay. Well, we now are going to have another talk, so I move world to yeah.
All right, sounds good. Now that Andreas showed us how to navigate the deceptively tricky waters of dates and times, thank you so much, Andreas, for helping us with that. It's quite a time warp to talk about times.
Yeah, I can unmute myself.
Oh, Andreas, you are here with us.
Yes, sorry.
No problem. Well, we can continue discussion. So everyone, please raise your hand to ask your questions. Else, it will be great for full communication. Please turn on your cam. Well, while we are waiting, let's little bit elaborate on topic that we started in online. So you said that what's the best options to store time zone data? You told us that it will be two fields.
Yeah.
Just local time zone and time zone name. I mean, not very important, not the offset.
Exactly.
What do you think about storing in database types like timestamp with local time zone? I know Oracle have one. I don't think Postgres has it.
The problem is that a timestamp, by definition, is UTC. So when you're storing a timestamp and the time zone information, so the time zone identifier, you're doing a calculation of the current local time into UTC, and then you store that with the local time zone. The problem is that it might be that at the time of calculating the local time to UTC, you have different information than you have later for recalculating. So you have now lost the information of when the actual event will take place. Imagine you have an event that will take place in 2 years' time in Moscow, for example. So we are calculating in 2 years' time, 10 o'clock, based on the current calculation rules to UTC. And we store the offset, we store the UTC date and the information that we are in Europe, Moscow, which is quite nice. But what happens now in 2 years' time? Because in 2 years' time, things have changed and Moscow decided to have daylight saving time. So now we don't have 3 hours offset, but 4 hours offset, for example, at the event, at the point in time where the event happens. But that was not the information that we had when we calculated that to UTC. So now we know, okay, we are in Europe, we're in Moscow, so now we have an offset of 4. So we take the UTC information and add 4 hours to that. No, take off. No, we add 4 hours to that so that we get the local time. And now we have, well, an offset of 1 hour to the original event time. And that is what can actually happen if you are planning ahead in, well, for more than I'd say 2 or 3 weeks.
Yeah.
So that's why I never would actually use timestamps for storing information, unless, as I said, it's some log informations that are happening right now. As soon as I'm more than 2 weeks in the future, I would always try to store the local time.
Okay, great. Do you think developer need to think about time zones if they develop, for example, application that is only one time zone located?
I would always think about time zones. And if it's only, yes, there might be a time zone, or there are time zones, and I have to take them into account because you never know whether the application will actually be only used in one time zone, or then suddenly the customer decides, oh, now we have a great business in the United States and we actually want to set it up there. It happens. And it usually happens, and then the pain is really, really big.
Yeah. We have some, I see we have some questions. Hey, people, just open your cam and ask questions. Don't hesitate. It's really simple. Sergey asks, what about the time on the border of two rules? I don't mean what it can be, because in my option, it's rather one time zone or just another. Not
Exactly. So it is either one or the other time zone. So there is no other option for the whole thing. And if you are right on the border, you have to decide in the end what time zone you're going to work with. And if you if you have an event or something like that, you just have to decide, okay, what time zone am I going to use? It is a conscious decision in the end. There should not be an automated way of saying you have to use this time zone. So I'm not 100% sure where that would be applicable, that you don't know which time zone to use.
Yeah. Alpha, when we discuss what was the best option to for users to tell us their time zone organization, another part of this question from Paul was how to handle this for backend operations, such as sending email at specified time and so on. For example, a user is from one time zone. He wants that his mail will be sent to him in a few days at some point in time. At the other time zones, are there some caveats here? Maybe you know. Or
yeah, well, you mean like the user said, I'm in this time zone and now I want my information in another time zone?
I know, I don't actually, Paul Dragonis, you can ask your question by voice and tell us.
Go ahead, Paul.
Yeah.
Can you hear me?
Yeah.
Go ahead.
Oh, okay. So the question was, it's easy. You described the problem being simplified by having the data stored in the back end and then sending that UTC time to the front end and using moment.js to render it for the local time of the user.
Yeah.
And that's easy because the browser is handling that, and that's problem solved. But what happens when you need to do an operation only on the back end, like you want to send an email to all of your customers at 9 a.m. on their time. And so how is the best way to handle this, but also capturing the question was in two parts really. It's like, how do we what's the best way to capture the information when the user signs up so that we know where they are, but then also when you're on the back end, how to make sure that your customers get an email at 9 a.m. on their side. Basically, there is no browser, so how do we try to get the localized time easy? Well, not easy, but it's the best way, really, the most effective way, so that it doesn't break.
That would be something where I actually would use the database time zone calculations, so that you can you create a select statement that checks, okay, what time zone is the user in, what time zone is the event in, does that match, and send out the appropriate information at a certain time, whatever the user wants, or depending on the user's time zone. So that, of course, is a backend operation that you can achieve by using the time zone information in the database, or time zone calculations in the database, or you have to import all your stuff, all your data into PHP, do the calculation there, which perhaps is a bit time consuming. So in that case, I would definitely think of doing that on the database side. Does that answer your question?
Yeah, I'll basically let the database do the work for me.
Yeah.
Got it.
And make sure that the database always uses the latest time zone information.
Yeah, don't forget to update your servers. Time zones. Yeah, we have another question from Sergey about border of two rules, which I started earlier.
Yeah.
I have some specification.
Okay.
He mean when about time ranges, when you have for example event which is a time range and it starts in one time zone and it can end.
Well, there is a very easy or very common event where that happens, which is flights. So I'm flying from Frankfurt to Moscow, and then the start event, the start date time, has one time zone, and the end date time has a different time zone. And yes, then you have to do some calculations like, okay, convert everything into one time zone and calculate the diff if you want to know how much minutes that flight might take or something like that. So that would be the way to handle that. If you want to do some date range information or something like that. I'm not 100% sure, but I think, as far as I know, the PHP, what is it, date, that there is a class for that, which is the date interval, as far as I remember, that you can create from 2 timestamps, so 2 datetime objects. And if those 2 datetime objects have different time zones, the date range will be created in the right way. So it will have the correct number of minutes and hours and days and whatnot as the difference. Does that help you?
I think Sergey will write their comment.
That was more like, Sergey, does that help you?
Yeah. Are there any other questions from chat, or maybe by voice will be great? While we are waiting for people to write their questions, let's talk about client side. Displaying date and times. Let's a little bit elaborate on how to display. I mean, when you find it's a good practice to display dates always in local time zones where it should happen, or there are some caveats for this.
No, I would always display times in the local time zone. So in the time zone the user has selected, because that makes it for them much more relevant and much easier to digest. It's easier for me to know, yeah, this is 10 o'clock. Perhaps add a local time zone or your time zone to that. Then oh yeah, that's 10 o'clock Phoenix time. Oh damn it! How much? What's the time in Phoenix at the moment, and how do I have to calculate that? I don't want to do that calculation. So if you have the possibility to display it in local time for the user, that's perfect.
Are there some cases where you cannot do this? Maybe you can show.
Yeah, well, you cannot do that calculation if you have lost information, like you only have a timestamp. Okay, now I have a UTC time, and I can calculate from that to my local time. That works. But I'm not 100% sure whether the calculation to UTC was correct in the first place. If it is an event in 3 years' time, that might be something completely different. If it's like log information, yeah, that works. So that should actually work all the time. I think that's rather pretty universal. What helps me usually is when something is calculated into my local time zone, that I actually have the information behind the time. Yes, this is your local time zone, so that I don't have to think about, do I have to recalculate that? Especially when you're handling international things. That is always a good information, but it makes it much more easy for me to understand if it's already calculated into my local time.
So basically, you mean a double recalculation when from one side, then I don't know, is it already the required time zone, or should I recalculate it another one?
Exactly. If you for example, during this conference, there were a lot of dates and information going back and forth, and that was always pretty amazingly handled, because it was always, yes, 11 o'clock our time, which means 10 o'clock your local time at this point, which made it easy for me because I didn't have to do the calculation, and I knew exactly, yes, you thought about that. So I didn't have to think about, okay, this is now 10 o'clock. Is that my time zone or is that their time zone? And do I have to check back? So having that information, and if it's only the information 10 o'clock, your time zone. Okay, they thought about that. I don't have to do any calculations. That makes it much easier.
Yeah, great. Well, are there any other questions?
Feel free to ping me via Twitter or via email. I share the links or the information on the slides. So feel free to ping me at any time you think, oh, I have a question that might be of interest or that I need solved, and we'll see whether we can get that done or not.
Yeah, all slides, talks will be available on site after talk, so you can contact Ping Andreas and ask something. Well, Andrea, thanks you very much for your really good talk. I hope that your discussion will help some developers to understand that there are some problems with time zones, so maybe not to solve all of them, but just to find and think about them in mind, have in mind that there are some circumstances when you should make some decisions. Thank you very much. Well, everyone, go ahead to another talks. We'll have many different talks today. Interesting. Stay tuned and see you next time. Bye, everyone.
Thank you very much. Bye.